Hello students, today we will discuss limit of sequences with proofs it is asking. So determine the limit of the following sequences and prove your claims. That means by definition also we need to prove the limit value. For that actual limit value we need to first find first, that is some sequence is given, then write the sequence, limit of that sequence, then how to find at limit at n tends to infinity, how to find, take the highest degree common in numerator and denominator. So n is the highest one, so take it n as it is. By what is the highest degree in the denominator? N square. So take n square as common, then 1 plus 1 by n square here, and gets cancelled. As n tends to infinity, 1 by n tends to 0. Obviously 1 by n square also tends to 0 because 1 by infinity is 0. So substitute those values, then 1 by n is 0 into 1 by 1 plus 0 here. So 0 into anything is 0. So what is the limit value here? L. Now we need to prove this limit of the sequence is 0 by using the definition of limit. Already we have discussed in the previous videos that what is the definition of limit, in the sense, for any small positive quantity for all epsilon greater than 0, there must exist some integer m such that modulus of Sn minus L less than epsilon for n greater than or equals to m. So when it is decreasing, then the value of Sn and L difference is almost equal. That is, they are very similar, because when you are subtracting the subtracting both, then it is a very small quantity. That means what? Limit of Sn equal to L. So it is approaches to L. So how you can represent in an definition of limit? For all epsilon greater than 0, there exists m belongs to n such that modulus of Sn minus L less than epsilon for n greater than or equals to m. So this we need to prove. For that, consider this part. So modulus of Sn minus L, here instead of Sn, An is given, of course. So modulus of An minus L. Now what is the process? For every problem we have the same process, only the sequence is different, the process will be the same. See once, An, substitute An here, minus what is L value here? 0, substitute here. Then this minus 0 is nothing but this. And what is the first step means? Numerator should be independent of n. So in the numerator, n should not be there. So what we need to do is, we have to eliminate n by taking the common. So n, take it as it is. Here when you are taking n common, then what will happen here? 1 by n here plus 1 by n. Now n gets cancelled. Now in the numerator, n is not there. So this is the first step. What we have to do is, modulus of An minus L you need to consider. Then simplify up to what? It should be independent of n, which is the numerator. Right. Now this is taken as equation 1, and take this part, n greater than or equals to m. Obviously when you are taking reciprocal, what will happen? That sign will be reversed. That is, suppose when you are taking 3 greater than 2, suppose, then when you are taking the reciprocal, what will happen, girls? Obviously it is less than 1 by 2, because when you are taking one circle into 2 equal parts, 1 by 2 is the 1 by 2 is this part. Suppose you are taking circle into 4 equal parts, what will happen? This part will be very small. So in the denominator, suppose when you are taking into 3 equal parts, then 1 by 2 is greater than 1 by 3, because when you are taking into 3 equal parts, what will happen? This quantity will be decreased. So when you are taking the when you are increasing the denominator, then the value is decreasing. So when you are taking reciprocal of 1 by 3, obviously it is less than 1 by 2. So here n greater than or equals to m, 1 by n less than or equals to 1 by m, taken as equation 2. And for every problem you need to take the same steps, and also by Archimedean property, which is also we have discussed in the previous video. See once, for all epsilon greater than 0, there must exist one real number m such that 0 less than 1 by m less than epsilon. So epsilon is a small quantity, of course. You take any real number, then you are taking the reciprocal, what will happen? It will be decreased. Like suppose you are taking m is a real number 100. When you are taking 1 by 100, what will happen? When you are taking one circle into 100 parts, only single part is nothing but very small quantity. So what is in the sense, for Archimedean property, you may take any real number, then when you are taking reciprocal of that real number, which is a small quantity, which is less than epsilon. So what is Archimedean property? For all epsilon greater than 0, there exists a real number m such that 0 less than 1 by m less than epsilon. So from these two, what we can say? 1 by n less than or equal to 1 by m, but this 1 by m is less than epsilon. So from clubbing these two, what will happen? 1 by n less than or equals to 1 by m, 1 by m less than epsilon. So from this we can say 1 by n less than epsilon. So taken as equation 4. Now always, what is the next step means? Always you need to compare n with the denominator of the actual problem. So what is the denominator here? N plus 1 by n. Always this denominator compare with n. So what will happen? Obviously, n is less than n plus some fraction of part, isn't it? Suppose I am taking here 2. Then when you are adding 2 plus some 0.0001, then also this will be greater value and this is the less than value, isn't it? In the same way, when you are adding n to any small quantity, then it will be obviously the greater one. So n is less than n plus 1 by n. Why we are taking like this means this is the denominator of actual problem. So we need to compare always the denominator with n. So n is obviously less than this part when you are taking the reciprocal, because this is in the denominator in the problem, that's why we are taking the reciprocal. Then reciprocal means less than changes to greater than, already we have discussed previously, right? Now a greater than b we can write as b less than a. So suppose 3 greater than 2, then we can also write 2 less than 3. So in the same way, take this first, then it will be less than 1 by n. Now from 4 and 5 what will happen? What is 4? 1 by n less than epsilon. But here from 4 and 5, this is less than 1 by n, but 1 by is less than epsilon. So this is less than epsilon. Now from equations 1 and 6, in equation 1, in equation 1 we have modulus of an minus l, that is modulus of this minus this is nothing but this. Already we got this value is less than epsilon. So from this 1 and 6 what we can conclude? This is equal to this, which is less than epsilon, in the sense this is less than epsilon. So modulus of Sn minus L less than epsilon means, in notation how you can represent limit of Sn equal to L. So here it is like Sn minus L less than epsilon. So limit of Sn equal to L. Hence we proved by using definition. Similarly, we can do another problem. One sequence is given. What we need to do first? Take the actual limit value by using the normal process. So limit n tends to infinity. Here what is the highest degree? N power 1. So take n common here. Then 7 minus 19 by n. Similarly in the denominator, n taken as common, then 3 plus 7 by n. N gets cancelled. As n tends to infinity, 1 by n value tends to 0. So substitute 7 minus 19 into 0 by 3 plus 7 into 0, which is nothing but 7 by 3. So L value is 7 by 3. So by using the limit definition, already we discussed that for all epsilon greater than 0, there exists m belongs to n such that Sn minus L less than epsilon for n greater than or equals to m. So here given instead of Sn, Bn here. So Bn minus L consider, then Bn minus L. Now take LCM, 3 into 3n. So 3 into this part minus 7 into this part. 21 minus 21 gets cancelled. Now it will be what? Minus 106 by 3 into 3n plus 7. Here modulus of means it may be absolute, that is positive value. Take it as it is, equation 1. Now this value is nothing but what? This value. So we need to prove that this is less than epsilon. For that, obviously same as previous problem, these steps are same, because for n greater than m always 1 by n less than or equals to m. Always by Archimedean property, 1 by m is less than actually epsilon. But in the numerator here 106 is there. So according to problem, for our convenience we are taking epsilon by 106. What will happen when you are taking a small quantity? Again we are dividing this 2 parts, then it will be very small. Dividing with 4 parts, it will be very small. So when we are taking a small quantity divided by 106 parts, then what will happen? It is decreased as a small quantity. So there is no difference between epsilon and epsilon by 106. That's why what we need to take. Why we are only taking 106 means it is in the numerator 106. To prove that it is less than epsilon, we need to take here by 106 for our convenience, right? Now same as previous, 1 by n is less than or equals to 1 by m, but 1 by m is less than this part. So 1 by n is less than epsilon by 106. Now compare the denominator with n, means obviously 3 into n is greater than n. So when you are adding 7 into 3, then it will be obviously the greater one. So n is less than this part. So take the reciprocal as it is. Then this less than 1 by n. Now 1 by from 4 and 5, what we can say, this part is less than 1 by n, but 1 by n is less than 7 epsilon by 106. So obviously this is less than epsilon by 106. Now here divided by 106, take it into this side, what will happen this side, then 106 by 3 into 3n plus 7. So here we got the same part. That's why instead of epsilon we are taking here divided by 106. Okay. So see here, this is less than epsilon. So in equation 1, what is that? This is less, this is equal to 106 by, but 106 by 3 into 3n plus 1 is less than epsilon. So this is less than epsilon. So Sn minus L less than epsilon means limit of that Sn equal to L. That's why it proved by using definition. Similarly, we can do the same another problem with similar method. So here obviously by seeing the question we can guess the degree is same for this. So the answer will be 4 by 7 for the limit value. Let us see. Limit n tends to infinity, same. Here n common because this is the highest degree, and when you are taking as n tends to infinity, 1 by n tends to 0. So answer will be what? 4 plus 0 by 7 minus 0, that is 4 by 7. Now this is taken as L, and by using the limit definition, write the same definition, write Sn minus L. Now take the denominator LCM, then 7 into 4, 28n plus 21 minus 28n plus 20. Again gets cancelled. This is 41 by, so what you observe here, denominator is 41. So instead of epsilon, what we need to keep? Exactly, epsilon by 41. Now what we have to do? So take as it is again. So for n greater than or equals to m, 1 by n less than or equals to 1 by m by Archimedean property, this is less than epsilon. So 1 by n less than or equals to 1 by m less than epsilon. So for our convenience, what we have to keep here? Epsilon by 41. Now here 1 by n less than epsilon by 41. Now compare n with the denominator of the actual one. What is in the denominator? 7 into 7n minus 5. So obviously n means 7n is obviously greater. So n is less than 7n. When you are multiplying with 7, it will be more greater. That's why n is less than this part. Take the reciprocal. Then this is less than this. But from the above, 1 by n is less than what? Epsilon by 41. So from these two, this is less than epsilon by 41. Now by 41, take it into this side, 41 by 7 by 7 into this one. So it is nothing but actual value. This is equal to 41 by 7 into 7 and minus 5, but this is less than epsilon. So this is less than epsilon. Understood? I repeat, this value is equal to 41 by 7 into 7 and minus 5, which is in equation 1. But this is less than epsilon we got. That's why this part is less than epsilon. So limit of Sn equal to L. I think you can do this problem whose limit value is 2 by 5. Obviously same as previous problem, only numbers are different. Again by definition we are writing here, and we have here 16 in the numerator. So we need to take as epsilon by 16 and take the denominator, compare with the denominator. Same we are getting the answer. Just try yourself. See here. Same process up to here and compare the denominator here. So we got here epsilon by 16. So by 16 take it into this side, then 16 by, which is nothing but from equation 1. This is equal to this value, but this value is less than epsilon. So this is obviously less than epsilon. So limit of Sn equal to L. Now here is one different problem. In the question, in the sequence, sin theta or cos theta or sin n or cos n are given as n tends to infinity, then we need to take the limit values of sin n, because when you are taking directly substitution, what will happen? Sin infinity, which we cannot define. That's why sin or cos terms are given in any sequence in the combination of n. What we need to do is sin limit values. What are the limit of sin? Limits of sin, minus 1 1, because sin 0 is 0 and it increases up to 1. Again the value will be decreased up to 0. Again these will be like negative numbers. So it ends with maximum value is 1 and minimum value is minus 1. So it can't be exceed than 1, it can't be less than minus 1. That's why always sign limits are minus 1 and 1. Now whatever the question is given, sin n by n is given, so whole divided by n for each and every term. Now we have the given actual sequence, but the sequence is in between minus 1 by n and 1 by n. So by seeing the question, we can have some theorem, that is by squeeze theorem. Three sequences are given, then apply the limits for the three sequences and find out the left sequence and find out the right sequence values, and both are suppose exist and equal. Then by squeeze theorem we can say the middle values also exist and equal to the same value. This is what squeeze theorem or sandwich theorem, which we had discussed in the previous video. Now by using squeeze theorem here, limit of this sequence, limit of this and limit of this. Now find out the limit value of minus 1 by n. As n tends to infinity, what will happen? 1 by n tends to 0. So minus 0 is 0. Similarly for right value is also 0. Then both values are exist and finite. Then the value is equal. Then what we can say, the middle value is also equal to 0. So limit n tends to infinity, 1 by n sin n is equal to 0. Now, by using limit definition, write the limit definition as it is. Then prove Sn minus L, Sn minus L less than epsilon. For that, consider this part. Again, this is sin n by n. What I said previously, n numerator should not contain n. So, take it into denominator. So, 1 by sin n is nothing but cosecant. So, take this into denominator, then it will be 1 by n into cosecant. Now, it is independent of n. Now, we have to compare with the denominator n cosecant, of course. Before going to that, as it is, n greater than or equals to m means 1 by n less than or equals to 1 by m. By Archimedean property, 1 by m less than epsilon. So, 1 by n less than or equals to 1 by m, which is less than epsilon in the sense 1 by n less than epsilon. Now compare n with the denominator. So obviously n less than n cosecant. Take the reciprocals, then it will turn to greater than. Again a greater than b can be written as b less than a. So this one is less than this part. But 1 by n is less than epsilon. From this what we can conclude, 1 by cosecant, n cosecant less than 1 by n less than epsilon. Now this is less than epsilon. But what it actually, 1 by n sin n minus 0 is equal to 1 by n cosecant, but it is less than epsilon. So from this what we can conclude, this value is less than epsilon. So by definition what we can conclude, limit of this part equal to L value, that is 0, hence proved. So like this we can do the limit of a sequences with the definitions. So by definition we can prove these type of problems, and tomorrow we'll discuss some more theorems on limit of a sequences. So thanks for watching.